Wouldn't it be nice if someone would just take care of all that global warming stuff? What if the government or some other organization just pressed a button and suddenly the temperature dropped by a few degrees and stayed there? It sounds crazy, but it's not impossible. In fact, there are quite a few ways to cool down our planet quickly. Let's look at 4 of them. Solar radiation management is the closest thing we have to a real-life cheat code for global warming. If humanity really wanted to stop climate change tomorrow, this is how we would do it. But the downside is that it also comes with risks that could potentially destroy the planet. So yeah, maybe don't try this at home. To understand how solar radiation management works, we need to know a little bit about what causes global warming in the first place. The sun gives off energy in the form of electromagnetic radiation. This includes everything from radio waves to visible light to X-rays. Most of the radiation that reaches Earth is in the infrared spectrum, which is invisible to us humans but can be detected by satellites like the ones NASA uses to study climate change. When this infrared radiation hits Earth's surface, some's absorbed by the atmosphere and re-emitted in all directions, and some passes through the atmosphere and hits the ground where it's either reflected back into space or absorbed and re-emitted. This process of absorption and re-emission warms up the planet. So if we want to cool down the planet, we need to reduce the amount of energy that gets trapped by the atmosphere. This is where solar radiation management comes in. There are several ways to modify our planet's energy balance with the sun, but they all work by increasing the amount of energy that gets reflected away from the Earth instead of being absorbed and re-emitted. For example, one idea is to put a bunch of mirrors in space that reflect sunlight away from the planet. Another is to create an artificial moon that would block some of the sun's rays. A third option is to inject sulfate aerosols into the stratosphere. This would involve putting sulfur compounds into the upper atmosphere, where they would react with water vapor and oxygen to form sulfate aerosols. These aerosols would then reflect sunlight away from the planet, cooling the surface. This method is currently the most feasible way to block sunlight from reaching the Earth. And it's been estimated that just 20 million tons of sulfur dioxide injected into the stratosphere would be enough to offset current global warming trends. But there's a catch. Sulfur aerosols also cause a lot of other problems, including acid rain, respiratory issues, and a hole in the ozone layer. And even if we could make all those problems go away, there's no guarantee that the temperature would drop evenly everywhere. The Arctic, for example, might not cool at all, and there's also the possibility that the aerosols could trigger massive volcanic eruptions. All in all, it's probably best to leave the sun alone. Okay, so blocking sunlight is an option. But what if we could just suck carbon dioxide directly out of the atmosphere? Sounds pretty futuristic, right? Well, it's actually closer to becoming a reality than you might think. Several companies are already working on developing direct air capture technology that would allow us to remove carbon dioxide from the atmosphere on a large scale. The basic idea is to use fans to pull in large amounts of air. One company called Climeworks has developed a system that uses a rotating amine-based liquid to capture CO2 from the air. Their system is currently undergoing testing in Switzerland, and once it's up and running, it should be able to capture about 1,000 tons of CO2 per year. Another company called Carbon Engineering is working on a system that uses solid sorbents. They've tested their system at a small scale, and they're currently raising money to build a larger pilot plant. Both of these systems are still in the experimental stage, but they're expected to be commercially viable within the next few years. At first glance, direct air capture looks like a silver bullet solution to global warming. After all, why wait until we burn all the fossil fuels when we can just suck the carbon dioxide out of the atmosphere? But there are a couple of problems with this approach. First, it's expensive. The cost of capturing 1 ton of CO2 can vary depending on the efficiency of the system and other factors, but it's generally in the range of $60 to $100. That means that removing all the excess carbon dioxide from the atmosphere would cost trillions of dollars per year. Second, direct air capture doesn't address the root cause of global warming, which is the burning of fossil fuels. Even if we could remove all the excess carbon dioxide from the atmosphere, we'd still have to stop emitting more. In other words, direct air capture isn't a substitute for reducing emissions. It's a bridge technology that buys us time to transition to a low-carbon future. So, what if we could find a way to get rid of all the excess heat in the oceans? Wouldn't that cool down the planet without affecting the delicate balance of energy in the atmosphere? Well, it turns out that getting rid of excess heat from the ocean is even harder than getting rid of carbon dioxide from the atmosphere. That's because the ocean absorbs around 90% of the excess heat caused by human activities. This excess heat is spread out over a very large area, making it difficult to target with existing technologies. One proposed solution is to use a fleet of ships equipped with giant pumps to extract cold, deep water and bring it to the surface. The cold water would then release heat to the atmosphere and sink down, creating a circular current that would pull up more cold water from the depths. But even though it sounds simple enough in theory, there are a lot of problems with this approach. For one thing, deep water tends to be full of nutrients that can cause massive algal blooms when brought to the surface. Plus, doing this could disrupt deep ocean currents that play a major role in regulating the global climate. And finally, it's expensive. Estimates for the cost of this approach vary, but it's generally considered to be prohibitively expensive. What about if we just melted all the ice at the North Pole? The Arctic region is warming twice as fast as the rest of the planet, causing the ice cap to melt at an alarming rate. But the melting ice has a positive feedback loop that makes the warming even worse. As the ice melts, it exposes darker ocean water, which absorbs more heat from the sun than the white ice reflects. This causes the ocean water to warm up, which melts more ice, and so on. If we were to somehow freeze the North Pole again, we would slow down the warming in the Arctic region and break the positive feedback loop. Unfortunately, it's not clear how we could do this without causing more problems elsewhere in the climate system. One idea is to use a fleet of ships to spray seawater onto the ice, which would cause it to freeze over more quickly. But doing this could disrupt the delicate balance of salinity and temperature in the ocean, leading to unknown consequences. Another idea is to use a giant mirror to reflect sunlight away from the North Pole, which would cool down the region and cause the ocean water to freeze. But doing this could have serious implications for global weather patterns. We just don't know enough about the global climate system to say what the consequences would be. And those are just a few of the ways we could try to cool the planet quickly. But they all come with risks that could potentially make things worse. Instead of trying to fight fire with fire, it's probably better to focus on reducing emissions and adapting to the changes that are already underway. Thanks for watching.